Good morning, everybody, and thank you for joining me today for our webinar, in particular, discussing digital twin simulation um, in regards to building models in AnyLogic and the type of simulations we can build. So I'm getting ahead of myself. Let me share my screen for everybody. So yes, today we are going to do a deep dive into digital twins of digital worlds. I've actually made some use cases and simulation models of, in particular, two specific video games and the other type of applications and areas that you could take your models. So, quickly to go over the agenda, as I've already kind of done, welcome everybody. Thank you so much for joining us. I'll be going kind of a quick little overview into, what simulation is, why does it actually matter, what do we use it for, and then in particular, how AnyLogic itself handles these complex systems that we'd like to simulate. And then moving on to the two different case studies that I've prepared for everybody today, one being the modeling of a virtual pandemic back in 2005, and the other modeling the currently live dynamic system of what we refer to as a galactic war. And then ending off on a tour of the AnyLogic ecosystem in terms of, well, how do we build these models? What does that model building process look like? And in this case of I'd like to actually take these simulation models I've built and deliver it to all of you attendees. So I'll also be going over the execution and deployment aspect of AnyLogic as well. So, for anyone who may be new to the world of simulation models or models in general, there have existed for a long time many different types of models. Whether it be every day we're making mental models in our head of how things are going to go or how my days are going to go, or I'm about to go into a grocery store. What's my route? What's my planning based off of my current grocery list? And the other form can be, boxes connected with lines, essentially UML diagrams, ways to either plan out a full scope of a process, a project, where assignment, allocation might go to, ways of visualizing a process. And then, of course, there's physical models as well. I have many, many fond memories of spending time with my grandfather on his model railroad. And luckily in Chicago, we have quite a few museums that each always have their model railroad section. And, of course, another type of model, if you will, formulas on a sheet of paper, many, many math equations, formulas, mathing out all of the different details of a system or an equation. And the most popular type of modeling, which is through Excel spreadsheets. I have lots and lots of data that I'd like to parse through, examine. Maybe I want to apply some formulas and calculations and output of said data based off of everything that maybe I'm editing, like I'm trying out different budgeting, different processes, different schedules, and I'm plugging in the math and seeing what the outcome is. But in particular, today we're going to be discussing simulation models, which what we mean by simulation model is we're particularly referring to dynamic simulation, which is a prospection or forecasting technique that allows you to take any, let's say, real world or planned system. In this particular example here, I have, let's say, deciding the forklift schedule or number of forklift operators dependent on all of the orders and the trucks coming in at our particular distribution center. And, changing the schedule on the fly and just seeing what happens in the real world could be very costly or dangerous to a business. So with this simulation model, you make that digital copy of your system. And what it allows you to do is forecast, look into the future, test out all possible scenarios, show me best case, worst case, optimize for all of them. Help me make a decision based off of the forecasted results. But Something that gets a little neglected in the simulation professional sense is there has existed for a long time another type of simulation, actually. Video games, whether it be a simulation of a lone starship trying to fend off and survive in an asteroid field to two people just bouncing up, I'd say it's a ball, it's more like a square, back and forth and counting score, whether it be a driving simulator that, an end user is going to actually sit in the chair and control the car and control said system of what is a simulated race. And of course, many, many different applications of different types of video games, whether it be adventure to strategy to fighting games. It's all, a digital representation of some system that in this case, users are interacting with and seeing what outcome. Am I gonna reach level 99 in Tetris to am I gonna capture Mew or Mewtwo at the end of the game? And in particular today, we're actually gonna do a bit of a deep dive into two particular game worlds that have created simulations of. One of which is an incident from the very popular MMORPG, World of Warcraft, and a virtual pandemic that was a result of what was purposely an infection in game mechanic that led to a bug where said disease mechanic accidentally got unleashed on the world. And the other example we're going to be diving into is what we refer to as the Galactic War in a video game called Helldivers 2, where us, the players, actually have to make decisions on, well, what front do we go to? Where am I going to go based on whether it be my orders, my own free will, that, I do have some choices that are given to me, but there's this ever living, ever breathing war that we as the players and our behavior and our interactions have a direct impact on. So let's actually examine and look at these particular incidents, starting with the World of Warcraft Corrupted Blood Plague incident. So way back in the day, of God, 20 years ago already, of 2005, they released this new boss fight, or this instance or dungeon, if you will, where one of the built-in mechanics of this guy here, this dragon-looking man, he's a lizard or whatever he might be, where players were receiving a disease, where I cast the disease on you. And per the mechanic, how it just worked was, okay, your disease, go in the corner, stay away from everybody, because the closer you get to me, I receive the disease. And once I get it, we have two options, either cure it, which hopefully somebody has the ability to do that, or heal through it. Like I'm still hurting, but I'm gonna keep taking medicine, or they're gonna cast healing spells on me to just fight through the pain, fight through the pain. And it was never meant to leave that boss fight. It was just a very specific mechanic that, was just a fun little, oh God, I got to deal with the guy who can spread disease, and we have to strategize for it accordingly. Now, what happened was certain players in particular, certain players of certain classes learned that they could actually summon or get the disease outside of the boss fight and bring it directly into highly populated areas. Areas where users who, let's say the level one player who, I just started the game, it's my brand new day, are all of a sudden entering a major city and faced with what would be an end game mechanic that they will have no business being near or being touched. So as the lower right screenshots kind of insinuate, it was kind of a bit of a massacre. It was not a lot of people could survive through it. So let's actually explore, well, actually made a simulation of, in this case, one particular city found within the game. And what I'm going to do now is kind of go over into, well, how did we develop it? How did we make this one-to-one recreation of this virtual pandemic way back in the day of 2005? So starting off with how we define our environment, how we define our cities, and the way people move through them, we are utilizing AnyLogic's built-in methodologies and libraries to define our city zones, the different districts, shops, NPCs that people might want to visit to. I actually define the physical aspect of all the walls, the rivers, the one-to-one recreation of what the actual physical layout of the city looks like. And utilizing the pedestrian library and a little bit of the process modeling library as well, I was able to simulate or capture all of the behavior of any entity that lives or enters the city, whether it be the players and they're gathering at the mailbox in the auction house or in the industrial district, to the NPCs that just 24 hours a day stand at the same exact spot at their store, to the ones that patrol around the city. And what we have done on top of utilizing the flow and the movement throughout the city is defining their behavior as well as agents, getting into the specific behavior of whether it be the agenda of a regular day, going to the city, I need to go there, there, and there, to, oh goodness gracious, this pandemic is breaking out. People are dropping left and right next to me. I need to run away. Some people trying to fight the disease, some people trying to self-quarantine, all the little random behavior that might occur in the system. And going into, well, how did we actually capture the spread of this disease? I already kind of discussed that I utilized the pedestrian library to actually determine the flow and the movement throughout this space. But in this case, for simulating the actual mechanic that was this, it was called corrupted blood plague. What we actually did here is inside of each of the entities that are moving through the system, we have defined an SEIR state. Now, what that means is they're either susceptible, they're infectious, and while they're infectious, they're going to spread the disease to other people within their physical proximity, or you're recovered. And there's kind of different mechanisms of recovery, whether it be a priest found you and casted the cure spell, to you fought through it, you self-healed yourself. You can't cure yourself, but I can still self-heal and survive. And once again, it is all contact-based spread. It's all about the modeling the physical layout and physical aspect of this city. And something that was especially curious about this particular incident and why it was so dangerous was due to a number of asymptomatic carriers. Now, what we mean by that is that so players were always programmed to potentially catch this disease and die from it. But because this was never meant to leave the boss room fight, uh, the NPCs could actually catch it and be infected from this and also spread the infection to other players. But they were never programmed to die from it. So we had these immortal asymptomatic disease carriers that, let's say, whether it be the guards that were just standing at the front gates, constantly coughing on each other, spreading it, and anyone else who entered, to was actually the most deadliest of them all is the group of school children going on their class field trip around the city while their teacher gives them a history lessons at very, very busy parts of the city. And they're so clustered together, this group of school children, that they keep just constantly in a loop spreading it around. And it continuously keeps going and going. And as they walk through the city, learning their lessons, they're just spreading it all over the place. And we get to view some of the behavior emergence that came with the system that even did get studied by members of the CDC, other virologists, because, before the wonderful days of lockdown and COVID, we had no real data, no real outbreak data to work with of, well, how will people behave? How will they react? How many people are going to try to flee and quarantine themselves? What are the problems with clustering and social grouping? Once again, back at those children were the biggest problem in this particular city. To, in this case, the intentional spreading. The whole reason this happened in the first place is because the particular players that figured out they could take the disease outside of the boss fight, they were trolling, they were griefing, they were, hee look what I did. I murdered and decimated not just in the city, but an entire game. They actually had to reset the servers and fix it because this virtual disease was so out of control. There was essentially no way of stopping it without hitting the pause and reset button. So let's actually take a look at what this model actually looks like and how it runs. So I actually have it already pulled up on my AnyLogic Cloud here, where I'm just going to run this simulation from my web browser. And I do have, oop, I brought the wrong one. Let's start with the first one where I just want to view the chaos. In this case, I can try to see any, oopsies, differences that could have been made by enable social distancing and determining, well, what's our social distancing rule, whether it be static, same rules apply, exactly 6 feet to the random chaotic of social distancing because, you know, not everybody is perfect. Not everyone is going to behave the same. Actually, let's just use this one. And I can choose an initial part. I just kind of chose an arbitrary. Let's start with about 500 players. And for now, let's not start it with an infector. Let's just see what the city actually looks like. So please allow it for a moment to initialize. There's a bit of this is the curtain, if you will, and all my actors are getting into their respective spots and places before I want to rise the curtain. So a little bit of model initialization. Especially because I believe the total number of entities in the city in the physical space is around 2,000, give or take. So it just takes a moment for all of them to get to their respective spots before they go throughout their daily actions and daily movement. So here is a nice live view of the entire city, and we actually can take a look at the 3D representation of what everything looks like. This will be very familiar with if anybody here did play World of Warcraft on the Alliance, go dwarves. Um, this will be a very familiar city. And what I've purposely done, if you can't tell, I personally played the game for many years, so I'm very familiar with the player behaviors, especially in terms of well, what's people's agenda? What are they going to do? Everybody has a different agenda, but there's some norms to it. In this case, the most popular area is always going to be the trade district because commerce drives everything, even in virtual worlds. And in particular, the most crowded hotspots you see here are the bank, the mailbox, and the auction house. The auction house being, it's crowded in there. People are squeezing themselves in on top, over one another. And in this case, by the way, all the movement you see for all these players as they travel throughout the facility, we are utilizing and leveraging the power in this case of the pedestrian library. So all of the actual movements of whether it be they spawn in, whether they're visiting an NPC, or just standing around and hanging out at a district, chatting away with somebody, all of the movement is just handled by these particular logic blocks. And I just define the environment, defined all of the districts, all the different areas, put in the different probabilities of behavior. I will just say trade district and dwarven being the most popular because commerce and industry, the most common things people are going to even do in this game. And maybe the less, exciting and more emptier parts of the city. In a particular case, before I start the chaos, we can even take a look at what's going on. How many players do we have? Where are they all hanging out inside the city? Whether it be when I first started the simulation to what's the current setting? Because yeah, some people are leaving, some people are entering. It's a live, living, breathing city, if you will. We haven't started the plague yet, so I won't go into the analytics of it. But and just for the sake of it, we can actually follow, whoopsies. Something with my animation went a little wonky. That's fine. We will adjust accordingly. Can't tell, a lot of moving pieces, a lot of animation. Even if you can't tell, I'm very excited to discuss this subject. This particular model here was a bit of a passion project of mine that I worked on my own time. Funny enough, since my first week here at AnyLogic. For anyone who's familiar with our AnyLogic training course, I finished the airport model and immediately was thinking about this particular use case and example of physical space spreading of infectious disease. So let's not follow anyone right now, but let's see what happens when one single person decides, tee hee hee, my pet is infected. I'm going to bring said infected pet into the city. And right now, I'm just going to have him choose the highest populated area. And let's actually go to a zoom in of that. If you could tell just from not even 2 minutes, and even there, it just made its way into the bank. It spreads really, really quickly, especially because I have introduced the idea of all these players in the city. They are different levels, they have different health, they are different classes. Let me pause it really quick while I spot them. All of those attributes, those uniqueness, because one person might get it and they're just instantly gone. They're level one, they're a warlock, they have no chance versus the level 60 warrior has enough health that he might, you know, tough through it. He can't heal himself, but he'll, maybe he just has enough health to survive. In a particular, let me slow it down just a sec before I lose him. We have just spotted the most dangerous aspect here right in the middle. We see the little black dots of the school children going on said tour to eventually, as you can see, they're all turning red and passing it forever along with each other. There's kind of no end to it. And even a funny little aspect here, if you notice, we have all these white spaces, and I purposely have them running into the wall because if you've played this game, who has not just hit auto run from the graveyard and just wait till they hit the wall and then start running normally again? Because what happens in the game is, yes, as you can see here, everybody is dying, but per the game rules, you get turned into a ghost, and you have the ability to walk back to your body and then be resurrected. And you could see all these people are doing as best as they can to run in and try to get their stuff. But spoiler alert, sure, they get their body back, but they immediately get sick again and they pass away. Um, I can attest to my visual representation is 1-to-1 to how the game itself looked like way back in the day. We're talking about like people demanding their money back because the game was so unplayable. Entire cities were on lockdown. And especially because once again, every person could die, but the NPCs are still there. They're immortal asymptomatic carriers. So, and I've actually implemented this a bit idea of, well, what if a bunch of priests decide they're going to try to come in and clean up and treat the city? Let me slow it down a little bit. You could see they do their best. Oh, they didn't make it. Here's another one come along. They're going to try to get those school children. Oh, nope. They keep trying. They can keep trying. I could send them in, but unfortunately, just due to the cooldowns of said diseases, there's they're gonna do their best, but then they end up just, healing each other and trying to cure each other in the end. It's unfortunately a bit hopeless. I mean, even if we now look at the statistics of this particular model, we could see a breakdown of, well, how deadly has this been? What's funny enough, there's not that many people infected, probably because, well, a bunch of them are ghosts and the rest are dead. For the NPCs, that 10%, even though it's a small amount, now mind you, I just infected the biggest area, biggest district, the highest number of people. Um, that 10% of those NPCs is still very deadly. And as you could see, all of these times here you see are tracking like how long people live for in minutes. It's not a long time. Even you could see the whole run back to the graveyard, try to get my body and then get out. You not even 6 minutes like of that process, 5 minutes of it is running back, and then barely a minute of it, and you're gone. You're dead. And kind of a live view of where everybody is as time has been progressing and even the total number of casualties inflicted by this particular plague. And one little fun thing, let me, perfect timing. We can even try to survive ourselves. Let me actually, the first option was just, hey, I just want to take a peek. I want to see what occurred with all the chaos. There we go. But in this case, I want to actually try to let's be a priest because that allows me to self-heal. Let's say I'm max health. I have as much health. And once again, these numbers you see are all based off of distributions from the game. I just pulled live historical data and I can choose, well, where are we going to start with? Let's do, for the sake of it, Cathedral Square. And we will take a moment for the model to run. But what I've built while this is initializing all the people behind the curtain, what we are doing is we're gonna be a particular player, and I've allowed via my user interface the mechanics to try to escape. There is, per starting with my own player, this little timer of well, eventually infectors are gonna come in. I believe I chose the coordinated attack approach for when you choose your own infector. Or no, maybe it's the single. You even have that like a group of players collaborating to completely decimate the city to one single jerk who wants to ruin it for everybody. And even before things are beginning, we can actually do things like let's just make a quick run to the Dwarven district, follow my player along, see what the day in the life is like for a priest. Oh, it's always very smoky in the industrial district. You could barely see 5 feet in front of you, and I'm most likely maybe working with a blacksmith or an engineer. And hey, let's head over to that trade district. And while this is happening, let's just hypothetically say, okay, we had a coordinated attack. And as you can see, it all happened very, very, very quickly. Those people all popped up in the various areas of the city and just immediately wiped me out. And unfortunately for my poor priest who barely entered the trade district, he has succumbed to the corrupted blood plague. Barely lasted about 5 minutes in the system, and I would even say more like 0.84 due to the timing of when I started the actual disease. So, fun little trip down memory lane for anybody who got to experience this like I did way back in the day. Super happy they decided not to recreate it. I don't believe they did for the World of Warcraft remake. And a little bit of extra under the hood before moving on. Once again, all of the logic of all of the movements you see is all handled by AnyLogic itself. So I have all of the NPCs, the various ones that jump to a position and stand there and just wait, to the ones who have to walk around, have their pre-built controls or patrol areas, patrol lanes, all the different ones. So, you haven't lived until you spent a good week following around computer NPCs and mapping out a day in their life. So that was just the first example of my first use case of the World of Warcraft one. And the second one is a bit more interesting and very relevant. I'm playing this one a lot these days, called Helldivers 2, where us as players are fighting and spreading managed democracy throughout the galaxy. And what Helldivers 2 is, it's a large-scale cooperative action game where hundreds of thousands of players, like when I enter the game, I am given orders, I'm given suggestions, we have to liberate certain planets, hold and defend certain planets. But what we are kind of told to do when we select a planet is we are performing particular missions, which all have an associated time it takes to perform it. But each of these actions, each of these missions determine the ownership of a planet. How much do we own it or liberated it versus how much the enemy has. Now, this particular game is real-time data, all driven by player actions. Whether we win the war, lose the war, gain ground, lose ground, it's all kind of up to us, the players, and driving those decisions and hopefully working together as a collective. And how I have actually captured and I've recreated an exact copy of this entire Galactic War, all within AnyLogic. In particular, I'm utilizing agent-based modeling, system dynamics for the actual flow of the battle itself, and a little bit of Java under the hood. But starting off with, well, how did I simulate it? How do I actually capture this in AnyLogic? Um, First, what I did is and created a system dynamics model inside of each and every planet, which pardon me, its liberation. But how that actual liberation, how that flow into the stock of whether or not is liberated is all driven by player impact. I have players that are agents, and that sort of autonomy that we have as players of choosing where to go, that collective choice of everybody else is there, so I might as well be there too. Or we have an order to go to then free that particular planet. All of that actions and impact and player numbers is all having an effect on the rate at which this system dynamics model or liberation is occurring. And ownership also happens as well. The ability of, okay, once we liberate it, it's ours. It belongs to Super Earth, which also insinuates we could also lose it as well. So what I have done in this particular model, in the last one with World of Warcraft, it was essentially a snapshot of the past, a recreation of what happened way back in the day when I was a kid. But in this particular case, for my Helldivers model, it's less to do with, oh, hey, remember when this happened? And more to do with, I would like to know the future. I would like to know, okay, based off of a major order, or in the particular example model that I've built, how long is it going to take for us to, let's say, liberate the entire galaxy? Not only how long is it going to take a particular planet, but I want to establish the movement, the mass movement of players between the planets and the ever-changing population, or i.e. number of players, and all of the adaptive targeting that is going to be occurring. Are we trying to focus on one particular faction? Is there certain planets in our major order we need to focus on? Are we just very close on that planet, so we might as well finish that off because we're almost done? All of these little behaviors have now been forecasted and sort of given a what if and show me the future, show me what's going to happen when Joel, the DM, decides I'm going to up the difficulty of all the planets so it's very difficult to take and liberate it. Which kind of brings me to a point of this idea of forecasting into the future. I keep discussing things like liberation amount, number of players, uh, uh, orders that are coming in, which is, let's be honest, all about speaking to the real world, this existing video game, and bringing in all that live data to then show me a forecast of it. And how this is done, in particular with AnyLogic, and what this model really is what we refer to as simulation-based digital twins. Now, every simulation model you could say is a digital copy or twin of a system. But what really separates these simulation models from being just a copy to a digital twin is this ability to you have this real world existing system. I'm utilizing, let's say, a manufacturing plant or a nuclear power plant, whatever, thing I want to be able to forecast for and see what the expected outcomes of the future are going to be. What makes my simulation model of that factory or nuclear power plant a digital twin is the ability to essentially automatically or feed in live data from the real world to feed that state of the system into the simulation to then make that forecast, show me the future, show me the worst case, best case, optimize for all of them. In the case of nuclear power plant, forecast to make sure I'm not going to cause a meltdown and show me all those results to then help me make a decision based off of it. And how I have done this in particular within this example model in AnyLogic is taking the architecture of what is the Galactic War map that I previously discussed, utilizing agent-based modeling and system dynamics, and integrating and connecting all of this live data from, this is a snapshot of just my Galactic War table in the game, but the state of the planets, the number of players, they even track things like shots fired, number of Helldivers died, number of enemies that have died. And luckily, all of that data can be accessed via the open source war data. And how that is actually represented is via JSON files. And so what we actually do is take the snapshots of the video game as a JSON file, and due to AnyLogic's capability, I have what I've been able to do is take all that data from the game into the JSON and be able to parse through it and feed it into my AnyLogic models themselves to not just capture things like planet states and liberation progress, but even player population trends. Where the first one is sort of a video game open source API that's speaking to the live video game, but the other one I actually took data from is Steam database charts. So I took all of the historical data from the past 6 months of player counts, and I just took the raw data and plugged it into AnyLogic to just give me a simulated example of how many players might be in this game and interacting based off of the historical data and the live connection data as well. Because when I'm forecasting the future, I have to make some assumptions of like, well, I don't want it to be static. It's not going to be, let's say, 200,000 forever. It's going to be up and down. And I have based those trends on said historical data. So let's actually take a look at this example. So one of the kind of big takeaways and differences, my World of Warcraft Corrupted Blood Plague, I was luckily able to just utilize all of AnyLogic's built-in logical aspects to, let's say, define the environment and all the physical flow. Now, in regards to Helldivers, recreating a galactic map isn't really a normal use case for a simulation model, and especially in regards to that JSON file and all the juicy data that translates to that overworld map of our galactic war. I had to do a bit of defining and definitions of my own. So I do, reference, in this case, let me open it up. I pull these live status and I wanted to bring in how juicy and how big and how much data is really getting fed into my particular simulation model that, yes, even looking at it, it is very intimidating. And what the heck does all this mean? And the long story short is that I was able to take all of the information available via these various JSON files that represent the state of the video game, and I was able to define Java classes that relate to creating static objects of all of the particular data, the home world information, the planet attack. These are kind of, I don't have any out-of-the-box Helldivers library like I did with the pedestrian library, but with AnyLogic, because I can kind of customize anything under the hood, I've kind of peeked open and cracked open the Java aspects of the tool and defined many, many of my own that easily allows me to essentially define all the different aspects of this video game into the AnyLogic engine. And I even have my custom little JSONifier object, which is a little bit of a Python tool as well, that allows me to easily parse and feed in all of that data from the video game. So let's actually let's just run it really quick and give a bit of a demonstration in here, and I won't do it right now because loading screens and take don't want to take up too much of your time. But this is right now a one-to-one copy of what the video game actually looks like. In particular, all the planets, who their current ownerships are, how many players are currently on the planet fighting for it, fighting for freedom, fighting for liberty, fighting for democracy, and we can step into the planet to get that. Oh, it was just taken. It was just liberated just now. So we can actually return to the Galactic War and see that that ownership has changed and everybody left. All right, plan is done. Good job, boys. On to the next one. We're going to keep going and going and going until eventually the entire galaxy is controlled by Super Earth because, freedom and democracy and liberty is what our galaxy needs. And I have these live views of what the war is looking like, who has control of the most planets right now, what is this live view of players. And once again, this is all based off of historical data that I've just pulled off of the Steam databases and plugged into AnyLogic. And this sort of live time view of ownership of planets as well. Um, Now, mind you, unfortunately, everybody, I won't be able to show how long the war is going to take, and that is by design. I enjoy this game immensely. I don't want to, you know, nobody likes the person that spoils the end of the story or the end of the movie. Uh, and so I have some little bit of projection in what this could sort of look like in this future where let's just say it's gonna take a while, boys, and girls and everybody, for us to eventually conquer, come on, the entire galaxy. So little bit of a video I made last night of some of the planet, a little tricky. I would have to highlight all of them. But we could see here all of the players jumping around, some of these planets getting taken, the future progression of like players actually having to make decisions. Guys, will we make it in time to complete this major order? What is worth it? Is a gambit versus just hardcore straight up throw the boots on the ground defense? What's gonna be the best decision for us as players to collectively make based off of the state of the system that has been thrown at us? And so far today within AnyLogic, I've been talking a lot about video game use cases, which isn't the most applicable. From especially my experience here, it's not everybody's really what is the big need of creating these type of simulation models other than for funsy? What if you actually need to build or recreate a real business application or real world system and get results from it? So in AnyLogic, we cover pretty much any and all business and practical applications as well, of varying degrees of level of detail. Whether it be inside the four walls of, let's say, a manufacturing center, a distribution, an airport, a shopping center, to what's happening just outside the four walls in our trucking yards, or our docking terminals, or our train yards as well, to large-scale supply chain models where, delivery of goods and raw products between facilities, to the more strategic, abstract level. And within AnyLogic, the ability to not only focus on these different levels of detail or abstraction is doable, but also capturing all of the complexities of all these systems is all possible, in particular with agent-based, or pardon me, with multi-method modeling. And for other use cases, like, today's subject is on video games, there has been tons of other real-world applications of AnyLogic. I'd highly recommend, if you're not familiar with it already, following our case studies that real-world examples of how this tool has been applied to find solutions to problems inside the real world across many, many, many different varying types of industries. And it's multi-method modeling that allows you to capture those complexities, levels of detail, and scalability as well. Um, for levels of detail, going to go back one slide really quick. Whether it be in the case of Helldivers, I built a strategic level model. I don't need to simulate the players and their actual missions fighting against the enemy. That's just not necessary for me. I just need to see the high level numbers and the flow at which the liberation's going to go throughout the galaxy versus the World of Warcraft one. No, 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 no. I want boots on the ground, one-to-one physical detail of the spread of this disease, in particular inside of one city. And um, I was able to capture all of those different levels of detail and complexity through the capabilities of all these different approaches. Even especially the power of, I really always want to bring this up, the power of agent-based modeling. That allowed me a flexibility of, in this particular case, the Helldivers model, where, I didn't have to, let's say, hard code each individual planet that is going to exist in the system. All I actually had to do here, we could see in my running, we've already liberated quite a few of them. I kind of have this blank slate because, once again, Helldivers is a living, breathing theme. I actually had a fun little panic last week because they updated the game and I had to update my model really quick, but it wasn't that difficult because I have modularized my model in such a way that they can add those lava planets, just like they did that this week. For apologies if you don't play, but they added a bunch of new planets, and because I already had this blueprint for one individual planet, that didn't mean I had to go in here and hard code the lava planets. It was just through the mechanics of, oh, the database found another new planet from the JSON files, add it in, load its particular data. And sure, the time it's going to take to liberate those lava planets is more difficult for us, so put in that parameter, modularize, and put in that difficulty input. And today we have only discussed a few of the different libraries, but AnyLogic comes built in with many different libraries that cover those different use cases that I have discussed. Where, yes, on my Helldivers, I did quite a bit of programming to recreate the system, but, not to, you know, uh, uh, hit on my own programming skills, but I did leverage the power of an LLM, a little bit of ChatGPT and Claude, in particular to help me understand that giant JSON file and all of that data. That would have taken me quite a bit of time to decipher and understand and research, as opposed to, hey, ChatGPT, can you help me build Java classes to help me define how I should be parsing through all of this really complex, lots of data into my simulation model. And once again, it's with these built-in libraries that the engine of the system is created out of the box. But through the help of ChatGPT, handling and integrating the more complex and requiring some coding and programming on top of it uh, uh, is completely doable, all within AnyLogic. A little bit of fun back and forth. I thought about sharing my ChatGPT with everybody, but no, a lot of arguing and a little bit of back and forth. But no, that's not how the AnyLogic engine works. No, you cannot have access to that constant under the hood variable. I know you're aware of it. Don't you dare touch it, though. Here's the one I want you to touch. And to the idea of AnyLogic, so far I've given you guys a little bit of a quick preview of how the tool looks both on the desktop application and the source of how I developed the model. But in particular, for my World of Warcraft one, I actually ran this model all from my web browser. In particular, I didn't want to run it locally because this one is more heavy on the computation side. So I wanted to leverage the power of, in this case, the public cloud, our demo version, if you will, uh, on our AWS server. And why I bring this up is because a quick little introduction into the AnyLogic ecosystem. So kind of joke back to the day, simulation models themselves would never actually see the light of day. They help us make decisions in the real world, but those decisions were made based off of paper reports that contained all the outputs of the simulation. That let's say me, a developer, ran and generated a paper report to give to my boss. Then I give it to my boss, he looks at it, goes, hmm. I don't like any of these outcomes. Try a different scenario. Okay, back to the dungeon with me to go generate another paper report. The simulation models would never really get into the hands of the necessary stakeholders. And so we've kind of categorized there's your modelers, people whom are developing the simulation models, who need to get them into the hands of our end users, our data analysts, our managers, our operators, our users who just want to relive the good old days of classic WoW and how horrible a virtual pandemic was, and then how we got to experience a real one a decade later. Um, and we have bridged the gap between the development of these simulation models and the execution, all with our AnyLogic private cloud software. So we still have our desktop application where you could develop the simulation models and run them and run those different experiments. Helldivers run endlessly until every planet is owned by Super Earth and report to me how much time it's going to take quite a bit at the moment. But I need to take that tool. Let's say for you guys, the other Helldivers who might be in here, I want to give you the ability to run that simulation, find out if we're going to fail the major order, tell you the best planet to go to. And this AnyLogic private cloud allows you to take any model you develop and share it all through a web link. And mind you, in this particular case, it will be installed on our AWS server. We have the private cloud option, which would be, let's say, your AWS server or your physical servers as well, or through whatever cloud provider of your choosing. And I will actually be sharing some of these models in particular, such that you get to run them, play with them yourself. So I'll be sharing that at the end of when I stop my screen. I'll actually be pasting this little link in some follow-up materials. It'll be there too. So you can actually play with this particular simulation all through the web browser. And as it pertains to, that digital twin that I made of the Helldivers campaign, all of that data connectivity, whether it be that living, breathing digital twin implementation to snapshot capturing to, even in one case, as I was working on the Helldivers and I could develop it further. For some context, I made that model in about a month versus the World of Warcraft one, which was a passion project of about 6, 7 years, but on my own time. Um, but I was already thinking like, ooh, I can incorporate machine learning to determine the player rate, and I could utilize some other AI and other optimization tools to drive player choices and make smarter decisions as opposed to my loop through the planets and make some decision based off of current liberation rates. All of that connection, whether it be to the data or external solvers that is complementing our logic, all of that connectivity is maintained throughout the entire AnyLogic ecosystem, such that in the case of Helldivers, I could share it with you guys and you could load your own snapshot or just have that live view of what does the system currently look like and show me what today is going to end or tomorrow or the next week or the next year. Spoiler alert, guys, it's going to take a few years based off of the current system. We need more divers. And this type of capability really allows digital twin delivery at an enterprise level, where that ability to easily take the state of the real world system and feed it into the simulation model is all doable within inside the entire ecosystem. And especially in regards to something, if I have a little bit of extra time, I'll create custom UIs and share it with you. But the minute the model gets uploaded, as I previously stated, it's all a Java application under the hood. But what I will hopefully be doing in the near future is actually building my own custom user interfaces for, let's say, the Galactic War. So similar to all the fan-made little apps you see and all the Galactic War status. Um, you can essentially take any model you build and have APIs on top of it to either, let's say, call it from an app, create my own custom user interface. Maybe in this case, for data analytics guys, I like to view my data in Tableau. I don't want to look at this AnyLogic Cloud user interface. I want the data out of it and immediately load it in the Tableau server. That can all be done through Java API in that particular example. And within your simulation model and this entire ecosystem, that ability to, let's say, add hooks or connections to whether it be data points or learning agents or solvers or whatever it might be, this entire flow can all be managed and handled within the AnyLogic ecosystem. So thank you so much, everybody, for joining us today. And we'll take a few moments to answer any questions that you might have. So apologies, I am looking through your questions just now. I'm going to kind of prioritize the one that relates to the models themselves. I see quite a few technical questions, which I already want to start sending you guys some documentation on. So, thank you everybody for all your questions. There's quite a few. This is awesome. So, something that comes up very often I'm noticing is all the data connections. Now, AnyLogic itself, as I've mentioned, is a Java application, which means out of the box, any tools, any software, in this particular case, any databases, stick with the database option. If said database has JDBC connectivity, you can out of the box connect it with AnyLogic, whether it be an SQL server, Postgres, anything with a JDB server. And uh, on that note, essentially any third-party application or data set that has Java connectivity or Python connectivity, it can be connected to your AnyLogic model. And in terms of how we can sort of proceed, I'm trying to answer a bunch of questions at once. With said data and the time dilation, it's really up to you. For my Helldivers model, my time dilation is set in hours due to a bit of a development choice on my end, because I'm relying on system dynamics. The flow and rates that are all defined as the dynamics flow is adhering to the time units that I define. I could simulate the war instead of watching it hour by hour. I could watch it by the day or by the year. It would mean I would have to do a bunch of extra math to scale down the flows and the rates, but it's all doable and possible within any logic. Some questions about how long it took me to build the model. The World of Warcraft one was a passion project of mine that I worked on for about 7 years, um, on my own time, which is well, the real reason why it took as long as I did, because I was just working on my own personal time. Pardon me, when I had the opportunity. And then maybe a good 2 to 3 months of when it was like decided that, hey, let's make a webinar, let's make a presentation. Okay, it was 2 to 3 months of me going into the game, following around these NPCs. That was what took the longest, is data gathering, not capturing the system. That was the easy part. It was data gathering, which is the most time consuming. I've seen a few joke questions. What did I mean? I was a dwarf. Fury Warrior. Forgive me, I was like 12, 13 when I first made the class. Min-maxing wasn't a thing. We were all ignorant at the time. Um, So I see a few more questions about Python and data functionality and even questions about getting started. So within AnyLogic, we have, discuss the getting started. We have tons and tons of open source documents, resources, and even a free edition of our software that'll allow you to even get started right away. Anybody who's joined us can, let me share my screen again, can find here at anylogic.com. You have the ability to download the personal learning edition. You could reach out to us if you're interested in a university or a professional license. But what I would recommend for anybody's first steps is to check out under resources. We have this get started page that goes over, we have built-in tutorials, we have textbooks and literature. We have what I highly recommend official training. We'll be releasing our 2026 dates pretty soon. And those are kind of the three big starting points: documentation, tutorials, and training, which, let's say you went with those three approaches, you'd be kind of good to go with, let's say, I want to recreate Jeff's World of Warcraft model, but for Ironforge, yeah, you'd be good to go. If you want to do Helldivers, you would need a little bit of know-how with programming in Java and Python, but that's also where any logic support team can assist you with as well. All right. One last question. So, yes, it is when it comes to the populations of the players, it's sort of there's no physical representation. I'm not like creating like and drawing a player that's going to be boots on the ground planet for my Helldivers model. That's sort of he lives in the airways, the radio waves, if you will, that still are having an impact on said system. In this case, the stock and flow of our war. But there's no physical representation of Helldivers, let's say, going and completing a mission because that was just unnecessary and overkill for my particular use case. And there's a few questions about leaving the webinar. So yes, all materials will be recorded and available online. So thank you, everybody. I do see quite a few other questions that hopefully will be answered that are a bit off topic to this webinar. So thank you again, everybody, so much for joining us. It was a little bit off topic and not the normal type of presentation. We figured last webinar of the year, let's have a little bit more fun. If you can't tell, I'm a big fan of video games. Even back here is the OG simulations of simulation of a football game to a simulation of driving to playing basketball to hockey, and that's like a off-brand Pong right there. So thank you so much, everybody, for joining us today. And have a happy new year and a happy holidays.